Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 2, Lesson 1, Independent Practice. Problems? Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's do Module 2, Lesson 1, Independent Practice. Remember to put your name. Number 1, simplify. 5, parentheses, 2 plus 8x, close parentheses. Remember, this is saying 5 sets of 2 plus 8x. So remember, if we were to write this out all the way, we would have 5 sets of 2 plus 8x. That'd be 2 plus 8x, 2 plus 8x, 2 plus 8x, 2 plus 8x, 2 plus 8x. And so we'd have 5 2's and 5 8x's. Our shortcut is to distribute and say we have 5 2's and 5 8x's. And so then we multiply. 5 times 2 is 10, and 5 times 8 is 40, and then we still multiply by the x. So we have 40 x's. And that will be our answer, 10 plus 40x. In the future, as you move into algebra, you'll actually then rewrite this in order with the x's first and say 40x plus 10. But for now, we can just leave it like that. Both of these are correct. Number 2, we're going to simplify again. Negative 8, parentheses, negative 4, plus 9x. So let's distribute. Negative 8 times negative 4 plus negative 8 times 9x. Negative 8 times negative 4. Well, 8 times 4 is 32, and a negative times a negative is a positive. So I'm going to put this little positive here to remind myself that I dealt with those negatives and they turned positive. It also tells my teacher that I know what I'm doing here and I didn't just forget about those negatives. Plus negative 8 times 9x. 8 times 9 is 72, and it's negative, and it still needs to be multiplied by the x. So now I can simplify this further. 32 minus 72x, and put a box around the answer. Number 3, simplify. 1/4, parentheses, negative 36x minus 24. We're going to distribute. 1/4 times negative 36x plus 1/4 times negative 24. 1/4 times negative 36 times x. 1/4 times negative 36, I'm going to put it over 1, and then times x. Now I can multiply these fractions straight across and deal with this first. So 1 times 36 is 36. Of course, it's still negative, so we'll put that there. 4 times 1 is 4, so we'll put that there, and then put my x on the end. So now I have 36 divided by 4, and it's negative. So what is 36 divided by 4? In other words, what times 4 will equal 36? It's 9. And it's negative. So we have negative 9x. Now notice something, because we have an interesting relationship here. If we are going to multiply by a fraction and it has a 1 on top, such as 1/4 or maybe 1/2 or maybe 1/10, if we have a 1 on top and a number on the bottom, and we multiply that to a whole number, that whole number is basically being divided by the denominator. Do you see how that worked? Negative 36 divided by 4. After we did all that work, that's what we got, 36 divided by 4. I'm going to do the same thing here, but I'll shortcut it just a little bit. Eventually you can shortcut this much faster. But I'm going to put the 24 over 1. 1 times negative 24, if I'm multiplying straight across, is negative 24. And 4 times 1 is 4. So see, it happened again. Negative 24 is being divided by 4. So what is that? What is 24 divided by 4? In other words, what times 4 will give us 24? The answer is 6. And since 24 was negative, 6 is negative. Let's bring it down here and finish our answer and put a box around it. Number 4. Which property is shown below? So we'll say which prop. You know I'm a fan of abbreviations. And it shows 5y plus 0 equals 5y. So what we have here is a number plus 0 equals itself. So a number plus 0 equals itself. So we're writing this out to show that we know what's going on here before we put the answer. Because if we just put the answer, we're not explaining or proving mathematical reasoning. So that's why we are writing this out. So a number plus 0 equals itself is the identity property. A number plus 0 is still going to be the same thing. Its identity has not changed. So identity and we're adding, so it is of addition. And again, I'm going to abbreviate. So it is identity property of addition. In other words, you could say additive identity property. And you will need to say it both ways on the test. So identity property of addition or additive identity property. Number 5, another which property question. 3/5 x plus negative 3/5 x equals 0. So what's going on here is the same thing that we learned about in Module 1, where we have a negative number, negative 3/5 x, and we have a positive number, 3/5 x, and they're opposites. So this is a number plus its opposite equals 0. So that would be the inverse property of addition, or additive inverse property. So I wrote those two different ways. I know this is identity and this is inverse, but this one says of addition and this one says additive inverse property. Be able to recognize both of those. Number 6, which property? Four x times 1 over 4x is going to equal 1. So let's say what's going on here. This is a number multiplied by its inverse equals 1. A number times its inverse equals 1. So this is the inverse property of multiplication rather than addition. Inverse property of multiplication. And again, I'm shortening it. We're doing some abbreviations. Number 7, which property? All right, we see parentheses, 5x plus 8y, close parentheses, plus 3y is equal to 5x plus parentheses 8y plus 3y, close parentheses. So did anything switch order or travel anywhere? Nope, nothing commuted. The only thing that changed is the association. At first, 5x and 8y were associates or friends, and in this one, 8y and 3y are now associates or friends. This is the associative property of addition. And I forgot to abbreviate property. So let's say what the mathematical reasoning is here. Numbers that are being added can be added in any order without changing the final value. In this one, we're going to add 5x and 8y first, and then we'll add 3y. But in this one, we're going to add 8y and 3y first, and then we'll add the 5x to that. So numbers can be added in any order. That's kind of what's going on there. It's not the best definition, but it'll work. Let's do number 8. Which property? 5 times 2y times 3z equals 5 times 3z times 2y. So this is now changing the order. Do you see that? These guys flip-flopped. They traveled or they commuted. So this is the commutative property of multiplication. And so this is kind of like associating them, because we could do 5 times 2y first, or we can do 5 times 3z first. And instead of putting the parentheses, we just rewrote the order. So numbers can be multiplied in any order. That's kind of what we see going on here. Number 9. Which properties can be used to simplify the following expression? So which properties can be used? So we'll just go through it and we'll write down the properties that we use. So 10 plus negative 6 plus 17 plus negative 4. So the commutative didn't really seem helpful here, but we're going to use commutative here, and it's definitely going to seem more helpful. So I'm going to use commutative property to flip-flop or to switch places the 17 and the negative 4. So commutative. And I'll rewrite this 10 plus negative 6 plus negative 4 plus 17. Now I'm going to associate the negative 6 and the negative 4. Normally we would go in order and we'd say 10 minus 6 minus 4, but I can associate and do these ones first. So we'll do 10 plus, what's negative 6 plus negative 4? Ah, you're seeing the picture now. It's negative 10. And then plus 17. What's a number plus its opposite? What property is that? That would be the inverse property. Inverse property. So 10 and negative 10 is 0 plus 17. Oh my gosh, we have one more identity or one more property here. And I just said what it was, I gave it away. We're going to use identity property. A number plus 0 is equal to that number. So this is identity. All right, let's do number 10. And just know that you could probably do this in a different order as well. But this is what sticks out to me and seems the most obvious. Number 10. A geometry teacher wants to purchase 15 compasses and protractors for the students in his geometry honors class. So a teacher wants to buy 15 compasses and 15 protractors. So 15 compasses and protractors. Each compass costs $3.50 and each protractor costs $1.25. So $3.50, $1.25 each. Write and simplify an expression using the distributive property to determine the total cost of the materials. So there's a couple parts here. First, we need to write the expression so in a way so that we can use the distributive property. So we're going to put 15 on the outside and then use parentheses, and we'll put $3.50 plus $1.25. Now, we could add this together first and then multiply it by 15, but the point of this is to use the distributive property. They want us to do that. So that's what we're going to do next. 15 times $3.50 plus 15 times $1.25. So 15 times 3 is 45, and half of it, right? 0.5 is half. That would be 750. Here, I'm going to show you what I'm doing. I'm going to use a generic rectangle. 15 times 3 times 0.50. 0.50 is the same thing as a half. This is the same thing as a half, right? 1 over 2 is the same thing as 5/10, which is the same thing as 0.5. It's all the same. So if you know your number relationships, you can do this quickly. 15 times 3 is 45. Half of 15 is 7.5. And then we can put those back together. So this would be, now again, I'm going to use some number relationships here. 45 and 5 is 50, and then I've got 250 left over. So 50 to 50 is what this is. 50 to 50. And I can do most of this in my head to do it quickly. If you want to do it the older way, the other way, where you do 3.50 times 15, You can't do this in your head as quickly, but it still works. So 5 times 0 is 0. 5 times 5 is 25. 5 times 3 is 15. 16, 17. Okay? Then we'll put a 0. 1 times 0 is 0. 1 times 5 is 5. 1 times 3 is 3. And then we have 2 decimal places. So let's put this in first. So 0 and 0, 5 and 0. And then 7 and 5 is 12. 3, 4, 5. And then I've got 2 decimal places, 2 decimal places, 5250. Since I can do a lot of this in my head, this way seems faster to me than doing this. But whatever works for you, you can use either method. All right, 15 times $1.25. I'm just going to use the rectangle here, $1 and 0.25. 0.25 is the same thing as 1/4. Okay, so 15 times 1 is 15. 1/4 of 15, well, that's going to be another half from the 750. Well, I know half of 7 is 350, and half of 50 is 25, so 375. Again, I'm doing a lot of that in my head, but I can prove it. If we do 15 times 1.25. I'll do that after I finish this. So 15, 16, 17, 18, 75 plus 1875. So let's do it the other way to prove it, to prove that my generic rectangle is working. 5 times 5 is 25. 5 times 2 is 10, 11, 12. 5 times 1 is 5, plus 1 is 6. Put your 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. 5 plus 0 is 5. 5, 6, 7. 6, 7, 8. And 1. We have 2 decimal places, so 2 decimal places, 1875. And now we can add those together. Now, I was going to say I don't have a shortcut, but I do see a shortcut because I see that the 8 and the 2 will make a 10. So 50, 60, 70. I've got 70 from the 18 plus 52. And now I have 50 plus 75. Well, I know 50 plus 50 is going to be 1. And then I've got 25 left over. So that's plus 125. So this is going to be 71.25. Again, I can do some of this in my head to, make it go quicker. I'm trying to show you what's going on in my head. But you can always do this the old-fashioned way. 50 plus 1875. 0 and 5 is 5. 7 and 5 is 12. Put your decimal. 8, 9, 10, 11, 1, 1, 5, 6, 7, 71.25. $sign. Now, this question wanted us to write an expression and then simplify it. So our expression is right here. It's 15 times 350 plus 125, and then our final answer is 71.25. All right, I hope you found that interesting, and let me know if you have any questions.